All right, hello and welcome. This is going to be an explanation of stellar parallax and stellar aberration. We're going to explain this from the geocentric perspective and a flat Earth, because one of these proofs comes with an additional supplemental evidence that the Earth is curved. So we'll definitely take a look at that and see what we can do about that. So quick reference for everyone who's not familiar, these measurements will be taken in arc seconds. To conceptualize that, think of looking at your field of view of the sky in 180 degrees for your field of view. And then if you could break the distance between 1 and 2 degrees into 60 sections, that would be 60 minutes of arc in between 1 and 2 degrees. And then you could break each one of those arc minutes into arc seconds, which would be 60 seconds of arc per arc minute. So you could break the distance, essentially, you could break the distance down between 1 and 2 degrees to 1/3600th of a degree. So that's what we're dealing with. And then when we get into the more modern observations, they actually say because of satellites and due to high altitude observations with that, where there's low atmosphere, they can get even more accurate measurements where they get into the milli and micro arcs, which is 1/3,600,000th of a degree and 1/3,600,000,000th of a degree, respectively. Now, these are more like digitalizations of accuracy and precision and all that. So who knows when we get to this level of it, but we'll go over the basics here. So when you Google stellar parallax, you get all these nice crisp triangles here. You get an Earth here, you get a sun here, start your observation here, you got a star there, and then 6 months later, the Earth has traveled 186 million miles. And then you take your second observation and you realize that in reference to background stars, there's a little displacement angle. And they say that this is only due to Earth's motion. Well, luckily we're dealing with triangles, and using triangles, using these observations, you can't disprove the heliocentric position either way. Our position would be that the sky is in motion, and the movement of the stars is what's producing the angle displacement. And like I said, because these are triangles, there is no way to falsify this using the small, near, and far angles. So good luck fighting a triangle. So real quick though, what is stellar parallax and what is it actually telling us? Well, we have stars out here. We have stars that appear to be fixed, and we have a slight displacement over time. So they've extrapolated that using parallax, which is a real thing that you could do to make distance approximations to things, and then you could measure those distances and figure out how good your approximation was, because that's the thing, right? Parallax is a real phenomenon. You can use it to make measurements. You can use it to make estimations, and based off of the baseline of the angle and how far away and what you're looking at is, determines the usefulness and the accuracy of parallax and how you're using it. So the way that they're using it here from these diagrams, it looks very reasonable, right? But what's actually happening is that the distance between the sun and the Earth that they say is 93 million miles, and then over the course of 6 months, where the observations where the Earth has traveled, around to the other side of the sun, will be 300 million kilometers or 186 million miles. And they say that with the 186 million mile baseline, they can get parallax angles all the way out to trillions, quadrillions, quadbillions, sextillions of a degree, right? Or I'm sorry, of a distance based off of these angles that converge at infinity. So again, we're looking at angles that look like this, but what's actually happening is we have two parallel lines that converge at infinity. Just trust us. All right. So again, not mutually exclusive to a heliocentric or geocentric, this observation. Now, real quick, in terms of parallax should be going in one direction, meaning that the star should be moving in the same direction, because if the Earth is the causal mechanism of the displacement as it's going around the sun, has to be going in one direction. Now, this is a paper from, let me see, I forget the year. Let me see if I can pull it up real quick. Dearborn. Real quick. Dearborn, no. All right, well, anyway. what's going on? I don't remember the exact year. This is the early 1900s. What's going on here is that astronomers were making observations, that they were recording their parallax observations, and they found that there was negative parallax. Now, there can't be negative parallax because that would mean that the Earth isn't the causal mechanism, the Earth's motion through space isn't the causal mechanism for the displacement. So the astronomers were like, hey, what do we do with these negative parallaxes? And then we have the guide on what to do with that from Sir Frank Dyson Watson, who did their probability fixes for everything. He was a real math wizard. So what he says here says, in the case of real parallax, it is given for the star of the small error. Determine the value of parallax may have an error which falls on the negative side, and we could just use his mathematical formula to determine that the parallax angle is absolutely fine, and there's nothing dubious, or nothing wrong going on with the model here. And then we have, when it's double the when there's two stars, because they're close together, they're going to have an irregular orbit or whatever. So they're saying that it's going to be faster because they're gravitational attraction. So it's just an error in the photography. So you can go ahead and count that as a posi. And then for the third, they say, okay, well, those background stars that we're referencing that are fixed, right? These fixed stars that we're referencing the displacement from, well, maybe those just moved. Okay. So maybe your reference moved. All right. Well, if that's the case, then, GG, you played yourself, player. But let's go ahead and continue on to the better proof, in my opinion, for heliocentrism. Now, they say that because these stars are so far away and their light rays come in parallel, and that the Earth is going around the sun, that there's an aberration to them, that there's an aberration to the starlight. So we'll get into what that means here in a second, but this is a conceptualization of what they're putting forward. And then we'll look here, and we'll go back to 1727, where James Bradley took his observations of the star Draconis Lambda or something like that, I think it was, over somewhere in London. And what he had set up was, this telescope was angled at like 90 degrees, and then he found that he had to tilt it slightly to keep the starlight in the center of the telescope. And over the course of a year, when you plot that out, the amount that he would have had to tilt it comes out to 20 arc seconds. So what they're saying is that there's an aberration of starlight that traces out to 20 arc seconds in the sky, and that it's relative to the latitude, meaning that if you were at the North Pole, the arc in the sky would trace out to be like a perfect circle. And then at the 45th latitude, right around London, where he was taking his observations, you would get more of an ellipse. And then around Florida, South America, etc., you would get a more pronounced ellipse, and then at the equator you would get a straight up line. So if you look at star trails at the equator or near the equator, you'll see that convergence and divergence to the respective hemispheres, and then you'll see that straight line towards the middle. So you can kind of conceptualize it that way. It's pretty much exactly what he's putting forward, and he's saying that over the course of a year that there's minor displacement, and when you ratio that angle against the speed of light, you get 30 kilometers a second. So this was the best evidence put forward for heliocentrism, because the Earth, if this model is true, the Earth moving around the sun, it has to be moving at 30 kilometers a second. So this is a good ratio for them. Unfortunately for them, and this was recognized at the time, especially by your boy Wilhelm Wellum here in 1898, where he goes over 10 failed experiments to prove Earth's motion. And the only positive one that he put forward was this ratio for stellar aberration. But he notes in there that this is kinematics. It's not, an actual proof, because there's no there's no experiment, right? There's no independent, dependent variable. So in kinematics, you make a measurement, and then based off of that measurement, you make future predictions of motion with no assertions of causal mechanisms or dynamic forces or anything like that. So what this means is this measurement cannot tell us if the Earth is in motion, or if the sky is in motion, or if there's a medium in between us that's in motion, translated from the rotation of the sky that's causing a slight drag that causes the aberration. So to figure this out, we'll have to introduce some independent variables and do some experimenting here, which we'll get to in a second. But quickly, let's run down the flat Earth explanation and geocentric explanations for this. So geocentric explanation, right, for the globularist, they would say that a potential explanation they could give is that the star field rotates every night, and to complete that rotation, it's happening very fast, and that creates a slight aberration over the course of a year, which is what's producing this. You could also say that that the sky is translating its motion down to Earth, and the ether wind that's translating that motion, there's a Fresnel drag, and that's causing that apparent drift in the starlight to make the aberration. So there's a couple explanations you could give for that. And then for the flat Earth explanation, because how do we explain the arc relative to the latitude, right? If we're on a flat Earth, it would be circles all the time, right? Unless we see in curved visual space, which thankfully we do. So here's a little diagram of a Vith-Miller torus, which is modeled after curved visual space. And what we have here is your left and right eye. If you take a sphere, a disc, and intersect it vertically, and then rotate that 360 degrees for both eyes, you would get basically this. So you see in like little latitude, longitude lines, and this creates a near field and far field, which has different optical compression rates. And to learn more about that, I definitely recommend going to adl.place and going to Shane's database and learning more about 69 miles per degree. So if you want to learn more about how curved visual space replaces the optical curve, or replaces the physical curvature of Earth, they say that's supposed to be there. There's all the math for all that to explain all of these celestial observations in that regard. So when you model all this out over a plane, it would all be the same. I'm not going to bother playing the videos here for this. So I'm trying to move on to the dynamics, to the experimental evidence that the Earth is stationary and that these observations prove that the sky is in motion. So like I was saying earlier, kinematics and dynamics, right? How do we make the distinction between kinematics and see if there is an actual causal mechanism for this motion? What is the causal mechanism? So we have Airy's failure in 1872. So Airy comes along and he says, hey, James Bradley, I'll help you out. We can see which is moving. So if the starlight is coming in at this angle, and I have to correct my telescope a little bit for it off center, so at 90 degrees, I have to tilt it just a little bit with no water in it, right? And with the slight tilt and no water in it, what's on the table, right? What's on the table here is that the Earth could be in motion at 30 kilometers a second, or the sky could be in motion at 30 kilometers a second. Okay. Now, what can we do to determine that is we'll fill the telescope with water. And when we fill it with water, oh no, my water, oops, I'm not on the right thing. When we fill the telescope with water, if the Earth is in motion, then the starlight will be slowed down. And when it gets slowed down, I will have to correct my telescope even further to keep the starlight in the center. And the predicted amount was 30 arc seconds of tilt. So they were saying they were going to have to tilt the telescope forward by 30 arc seconds in total over the course of a year. And what they found is that they only had to tilt it 0.8 arc seconds. So a fraction of an arc second, not even a full arc second, when the telescope is filled with water. What that means is the starlight is already coming in at that angle. It's apparent, right? The actual physical location of the star is unknown, and the light we see is its apparent location. And there's no real way to refute that. The only way you could refute that, right, is we'll get into this experiment. So the experiment was done under the hypothesis of a stationary ether in a moving Earth. So if there's a slight displacement angle, does that mean that the Earth is moving slow, or does that mean that there's no ether, right? Well, if the heliocentric model is true, then the displacement angle would have to be proportional to the Earth's velocity. Now, because that's not the case, that's no longer on the table. What's on the table is that the Earth is stationary with respect to an ether wind. So they say that their position of a stationary ether in a moving Earth is untenable. And they say that, they later go on to explain the experiment by saying, okay, well, we'll get into what Michelson, like why this experiment is so important, right? Why this matters. Because it didn't falsify the ether, it falsified the Earth's motion. And here's why. Here's why. So here we have Michelson Morley in his 1887 paper saying, talking on that Aries failure paper that we were just going over, that whole experiment. So he says here, but it failed to account for the fact proved by experiment that the aberration was unchanged when the observations were made with a telescope filled with water. For if the tangent of the aberration is the ratio of the velocity of Earth to the velocity of light, since the latter velocity in the water is 3/4 its velocity in a vacuum, then the aberration observed with water in the telescope should be 4/3 its true value, with a little asterisk here. So we're going to read the asterisk, and he says, it may be noticed that most writers admit the sufficiency of the explanation according to the emission theory of light, and the emission theory is that light is little corpuscles, so that's little particles, while in fact the difficulty is even greater according to the undulatory theory. And the undulatory theory is the wave theory, so light's just a wave. And it says, for the emission theory, the velocity of light must be greater in the water telescope, and therefore the angle of aberration should be less. Hence, in order to reduce it to its true value, we must make the absurd hypothesis that the motion of the water in the telescope carries the light in the opposite direction. So for the emission lads, and in modern times, for the dual particle quantized light particle lads, you would have to say that when the water hits when the starlight hits the telescope, it goes faster. It's traveling its normal speed, and then boom, it travels faster to get down here. It has to accelerate. Now this violates their conservation laws regarding how light works. That can't happen, because then it slows. So it speeds up to keep its proportional speed in here, and then when it gets out, it slows down back to its regular speed. That's obviously not what happens. And then for the wave lads, now remember, this is taken with a stationary ether hypothesis, right? So stationary ether out here, stationary ether inside the telescope. But because this experiment didn't go the way they wanted, they say that the stationary ether out here is different than the ether inside of the telescope. The ether inside of the telescope is moving, and it's carrying the water in the ether in the telescope is carrying the starlight in the opposite direction of motion. And that's noted from Albert Michelson, saying that's an absurd hypothesis. So that's unfortunate for the heliocentrists that believe that the Earth is in motion. And that's great for the stationary Earth lads and for the lads that believe in ether, or that adopt the ether model. You can explain it, the observations, directly, right? Electromagnetic propagation has a medium, and it's in motion with the sky, and that's causing a drift. And that's it. Very straightforward. All right, I hope that covers everything, and I hope everyone gets a chance to read these papers, especially Michelson Morley and Fazao, and where's the other one? Aries failure. Because the only explanation that offered by the relativist and the heliocentrist is to gaslight you. So when you have the knowledge, you can stand on it and not get gaslit.